Hello, everyone. Welcome. It is awesome to see everyone joining from around the world. I see the Netherlands, Chile, India, California, Florida, Australia. Thanks to all of you who are joining at a really inconvenient time zone or a time where you're at. Appreciate you joining live for what should be a really fun session here. I'm Daniel Whitenack. I'm founder and CEO at Prediction Guard. I'm really honored to have Arden Labs host this session about generative AI with Go. And we've got a lot to cover today. I'm sure all of you either already are using generative AI, you're interested in it, your companies are saying, you know, what are we doing with AI? Your board is putting pressure on you. There's market pressure. So hopefully we can demystify a few things related to generative AI today, but also show you kind of the basics of how to do some of those functionalities in Go, which is the best place to do it. So let's go ahead and hop in. I'm gonna share my screen here, and we'll just hop right into the topic. So, as I mentioned, I'm Daniel Whitenack. My background, I've spent 12 plus years in industry building up data teams and working on various projects all over industry. I most recently founded a company, Prediction Guard, in January of 2023, where we're safeguarding private AI models. And so my day to day is all about this generative AI stuff. I also co-host a long-running podcast on AI called Practical AI. So if you're into podcasts, would definitely recommend that you look that up. So the first thing that I want to do as we hop into this workshop is to really talk about large language models themselves and help you all build up kind of mental model for how these large language models work. Don't worry, I'm not going to show any crazy math formulas or anything. But I think for all of us, because all of us use these models now, even in our personal lives, it's useful to gain a little bit of an intuition about how they work. So that's what we're gonna do now. So I'm gonna pull up something here. So this is just a private chat interface that I have that's running a bunch of different models through our system, Prediction Guard. And what I'm going to do is just give a query and say, Go is something. All right. And you can see the kind of standard thing that you might get from any sort of, looks like it truncated there. Let's just change a setting. I'll rerun this. You can see kind of the standard thing that you might get from a chat GPT like interface, maybe some good information about Go. Go is a programming language. So what's actually happening under the hood here? We're using this model, Llama 3 model, which is a family of models that Meta released as open access LLMs, or large language models. But let's gain a little bit more intuition for what's going on under the hood here. So here's what I just showed you, an output from one of these large language models. And here I'm focusing on large language models because really there are more multimodal things going on, and multimodal meaning like text plus images plus video will be increasingly interesting. But the majority of the kind of real world enterprise use cases where people are finding enterprise value is related to large language models. So that's what we're going to focus on for the most part. So when I use this model, so when I use Llama 3 here, what's happening is I put in this input, right? Go is something. And it came out with Go as a programming language, blah, blah, blah. It completed it, right? So just some jargon. This is generally called a prompt, this kind of left side, what I put into the model. And then the completion is what the language model output out the other side. So if we dig in a little bit here, what's happening is this prompt is going into the large language model. Now, this might be a GPT model or Claude from Anthropic. In our case, it was Llama 3. And then what the model is doing is nothing more than, although it can be quite powerful when we apply it appropriately, it's predicting a next word or next token. So the model is taking those first two words, go is, and it's computing actually a probability for every other word or every other token or subword that it knows about. And then it's looking at the most probable of those and adding that as its first token or word in the completion. And then we just sort of keep on going. We iterate around this. You saw that text stream onto the screen. We just start iterating on that. So my first word might be A. And then secondly, it just adds that to the prompt and then says, well, what's the next most probable word? And maybe the first most probable word after that is programming. The least most word is flee or something like that. And so it just keeps going like this, filling in the output. Now here, what's interesting is you can basically tell that this is autocomplete. This is like autocomplete on steroids. It's a big, big model that does autocomplete. So how can that possibly be useful for all of these many things that people are using AI for? Well, if you take the whole internet of text and a bunch of also curated text that gives a bunch of examples of blog posts and coding documentation and literature and all sorts of things, podcast transcripts, all of those things that are across the internet, then all of a sudden this model can get really, really good at predicting a lot of different kinds of texts. And if I add in an additional layer on that to kind of add in an instruction to the model, then it can produce very probable outputs given a certain instruction. So what can happen is I can do question answering here. So we do a bit of customer service for my wife's company, Antique Candle Co., and they make candles. So customer service, I could prompt the model and say, answer this question based on the given context. And I could paste in some context from some previous chat messages or something, and then have it give an answer. And so it's very useful at that. But also I could just create a general chat assistant. I could provide an instruction to be helpful and friendly, and I get kind of a general chat sort of thing. But I can also do really interesting things. Like I hope all of you are using, Codium or GitHub Copilot or something like this. If you're able to, in my code editor, VS Code, I can just under the hood, Codium or Copilot, it's giving a prompt, something like this, where, hey, generate me a script that does this thing. And then I can output a completion of code. You can output completions of SQL. You can output completions that format text from one format to another, to do code translation, to do document summary. I mean, you all have seen all of the amazing use cases that are here. And this is why people have started talking about these models as a sort of co-pilot. So this model is able to complete instructions given some context over a sort of general purpose set of, a general purpose domain. I can prompt this model to do a lot of different things, which means that I can chain the actions of this model together to actually assist me or another human in doing a series of tasks. So in the case that I gave, it's like I'm assisting that customer service agent at Antique Candle Co. in responding to a user, or I'm assisting one of us in writing code in VS Code. Or in the case of an enterprise, I'm assisting someone filling out a medical form by parsing out fields from a transcription, or I'm assisting a content production team by creating drafts of blog posts, or whatever those sorts of things are. Now, just to give you a little bit of an idea, I've talked a little bit about models here. One thing that you all should keep in mind is kind of a model landscape. There's a set of closed proprietary models, which basically means that you can access these models only via API. You'll never be able to download the model and run it in any of your own infrastructure. You'll never even probably know how the model operates, but they're really good, right? We all know OpenAI is really good. On the other side, there's a couple of types of open models, and similar to like open source code, there's a variety of licensing concerns as related to this. So there's some restricted open models. The first generation of Llama models was like this. Then there's open permissive models that you can use for commercial purposes. And these are like Llama 3 and Mistral and DeepSeek and others. In this webinar, we're going to focus on the open models. The reason for that is the majority of enterprise users and teams are gradually migrating to these open models, even though OpenAI had a big market share kind of leading in this field. Most enterprises are thinking about integrating, like how they're going to integrate open models, not if they will. And that's due to reasons not because of cost primarily, but because of control and configurability. And they want to know where they're sending their data and what control they have over models and the opinionated product choices that they're making. Okay. So we're gonna do a few things in this webinar. Let me just tell you where we're going, and then I'll maybe stop to answer a couple questions. For all of you that are building AI, applications, whether that be in Go or any other programming language, I highly, highly recommend that you think about this sort of hierarchy of how to build your applications, from basic prompting to training your own model from scratch. 95% of enterprise use cases, in my experience, can be solved without even fine-tuning a model for your company, by just using kind of prompting and augmentation and chaining strategies. And for that reason, what we're going to focus on in this webinar is how to do a few of these prompting and retrieval strategies with Go and with open models. So we're really focusing in on the enterprise applicability of these things, where people are thinking about open models, and they're generally certainly not training their own model from scratch, but I think less and less even fine-tuning their own models for certain use cases, because the models are just pretty good at this point. Okay, yeah. So a couple of questions here. So some about vector databases. We'll talk about that a little bit later on in the webinar. So I'll pause on that one. Let me know if I don't answer it. What decides where to cut off that 1 to 30,000 probability of predictive text? Good question. So when each iteration of the language model, it predicts a probability for every single word or subword that it knows about. Literally every single one of them. So every single iteration, it's making 30,000 predictions in the case of a Llama model. And then it chooses the one that's most probable, or one of the most probable ones. Okay. Yeah, so I may be missing a few questions here. Does the LLM have a consistency scoring algorithm for its output to ensure that things hold together? Great question. So there's a parameter in most LLMs that you can set called temperature, which controls basically, it gets really boring if you always choose the most probable word. It's not very creative output. That's what people have found. So there's this setting called temperature that allows you to choose the variability, essentially, of the output. How much to shift those probabilities. The higher you set that temperature, the less consistent that answer will hold throughout, because it's just it's masking probabilities so that it doesn't always choose the most probable word. So it depends how you set it up. Good question. All right, let's keep going now. There's a lot that I want to talk through. This is I forgot to update this link. Sorry for those that are watching on the recording or now. The link that you want to go to is go GenAI/webinar. So on my repo, go genai/webinar, and you can see some of that code here that we'll be getting through. Another good resource, if you're interested, is this API reference for Prediction Guard. We have a number of open models available, and we just released our official Go client very recently. So in May. So if you want to check out that's another good resource that we'll be using. Our API operates in a similar way to other APIs, and I'm going to focus on these open models because that's what enterprises are really interested in. Okay. So let's get to it. I'm going to switch over here now into my code window. And the way that I've structured this repo is in 3 sections: 1, accessing LLMs; 2, prompt engineering; 3, chaining and augmentation. And obviously, we're going to start with 1 here, and then each of those includes a set of examples for how to do these things. So I'm going to use the Go client that I just mentioned for Prediction Guard, which allows you to connect to the Prediction Guard API, which has these models hosted already. Assuming you have a Prediction Guard key, you can access these models and try them out. What I would recommend is if you go to predictionguard.com and you want to try out a few of these things later after the webinar, we have a Discord invite here on the Prediction Guard site. So just click into that Discord and we'll make sure that you can try out a few things with some of these models. So go ahead and do that if you're interested later. But for now, let me just demonstrate how to do some of these things. So if you noticed here in my chat interface, the main thing that I'm doing is I'm giving a prompt to the large language model, and then I'm getting a completion because ultimately these models are big autocomplete models. And so I want to do the same thing here. So the first set of examples we're going to go through is just how to make these calls to a large language model and get output out the other end. So in terms of how to access the models, you can run them locally. You can run them behind a closed API, or you can run them through a platform like Prediction Guard. The thing is, most of these require specialized hardware. If you're running them locally on your laptop, you're generally limited in terms of how big of a model you could run. So here we're going to use the models that are already hosted on predictionguard.com. And the Go client, the way that you would call one of these is after setting up a logger and creating a new client. So from the Go client with a timeout, then you can just define one of these models to call. In this case, I'm calling the Hermes 2 Pro Mistral 7B model. A lot of these models have crazy names, but that's one of them. So calling this model, and on the client here, I'm just calling the completions method here and giving it a prompt. So the way that this works is I define the model, then I give it a text prompt, and then if I want to, I can define a max tokens value and a temperature value. So this temperature value, if it's low, like 0.1 or something like that, then you get less variability in the output. If it's higher, you get more variability. This max tokens will truncate your output. So remember, like when I'm here doing my completion, this sort of went on for a while. If I don't want my language model to just keep generating text for a while, I can actually force it to truncate at a certain number of tokens or words. So it's pretty simple. Define your client, set up the completion or call into completions with your prompt, and then we're just going to output the text out of that response. So here I go over to a terminal and go into our first example. I'm going to build that. Okay. And if I run that, then It's going to execute this request. And if you see, my prompt was the best thing about gophers is colon. And here they are smart, they don't bite, they don't carry disease. They're like little furry tractors that live underground and are great for composting. Wow, that's actually a really wonderful response. Although I do think that gophers bite and carry diseases, actually. So notice a couple of things about this response. This response is kind of it seems to be truncated because I put that truncation in there. I manually terminated it because I knew it probably wouldn't be that great of an answer. I manually truncated it. So you can see this just sort of cuts off here. But also, it seems to just like lose it just keeps going on and on. I guess I wasn't very specific in what I asked it to generate, but generally, this is on topic. Now, if I run this again, I'm not going to get the same thing. So I get something maybe similar, but not the same thing. I can run it again. I get something similar, not the same thing. Remember, I set up this parameter here, this temperature parameter, to give some variability. But even if I set that low, I won't always get the same thing out of these models. So that's one first thing to keep in mind as you're working with these models. One thing, though, that's more important probably even than that is all of these models unfortunately have a specific format of prompt that they expect. So these models are trained usually and fine-tuned to expect a certain format of input. And here I've just given like a raw text input, which isn't in any given format. If you're curious about these formats, you can go to this prompt formats page on our docs, and it'll tell you about all of the weird formats that are available to you. The model that I'm using here, this Hermes model, uses the chat ML format. So really, if I want a better response, what I should do is do something like this. I should use a prompt that is in the format that the model expects. And usually these include a set of special tokens that separate out certain portions of the prompt, like a system message, which is some boilerplate message giving instructions to the LLM, and then a user and or assistant messages that represent some chat threads if it's a chat trained model. So this is sort of a goofy format, but now if I run this time I'm going to ask it to write a Go program that prints out random numbers. I'm also going to set the max tokens higher because I expect this actually to give a great response and maybe truncate itself where it should truncate itself. So if I go back now to my example 2 and run this, then I asked for a Go program that prints out random numbers. And some of you that are quicker than I am, well, maybe this looks right, but hopefully it's right. And yeah, I get a nice little like assistant response, like here's your program, and here it even explains it a little bit for me. So the quality of this response is going to be better because I'm fitting the prompt format that was expected by the model. Now, this is super annoying. I'm sure that you don't want to be like dealing with all of these special tokens all the time, which are annoying. So in some APIs, including ours, we add a little bit of a layer of convenience on top, which is similar to what you'll see in other APIs that you'd be using for AI, which is a chat completions endpoint. So if you go here to this actually just takes a model and then this message thread input. And what we do is we have code under the hood that then converts that into the right format for you. So this is very typical for AI systems that you would be using, is to have a chat message thread type of format, and then the output the system to take that and apply the correct prompt format. So in this case, in this example, number 3, I'm still connecting to the same API. And I'm going to now, though, use the chat method here and provide as input a slice of chat messages. For each of these chat messages, I can put in a role, which could be user, assistant, or system, and a content, which would be the kind of message that I want to write. And this is exactly what's going on under the hood here in this example that I provided for this actual chat interface. Is this was put in as a message thread. This was the output. And if I continue this and say, great, summarize this in one sentence and output it in Mandarin. Okay, so now I have multiple messages that were sent. Those are tied together in a thread. And each of these under the hood can be represented as a chat message like this that's filled up. So that next one, once I have it, I can put it in as a role assistant, right? And then save that as part of the thread for future responses. So here, though, I'm just going to do the same prompt, Go program that prints out random numbers. Going to use the same model, increase max tokens. So let me just clear this out here. Oops. Get my hands on my keyboard in the right spot. And okay, so now I should still get a nice response. So you can see I again get a nice response, but I didn't have to do any of that junk around like prompt formatting my prompt, which is nice. So this is really a convenience piece of this. The other convenience piece that I want to mention is most of these. So if I run this again, okay, it takes a second. It's thinking, okay, it wasn't that long. Maybe it's like 1.52 seconds, which is actually pretty good for a full response from one of these models. These models are not that fast, but they can start generating text as soon as you give them your prompt or very quickly after. And this is what's happening, like what you see animated in this interface, right? Because I'm generating each of these words and then painting them to the screen as they come through. So how this most often works with AI APIs that you'll be using is as follows. And this goes for Prediction Guard as well. Most of these APIs will handle this streaming via server sent events, not a WebSocket or anything like that. So you actually send the message and then events are sent back to you. And those events are these partial completions. The way that this works in Go with the Go client is that you have create your new client just like before. In this case, I'm creating an input chat message. And I'm creating a channel then that will accept client.chat SSE types, which is long enough to include my full context length or my full max tokens. And I'm calling that model with my input. And then for the things that are thrown off of these choices, then I'm printing the content from each of those things. So this is much better visualized than it is said. So let me go back here. And just run this again. And now you can see I get that nice streaming piece. And it's much more user-friendly because I cannot wait for the whole thing to be generated. I can just get that printed right as the model starts to print because I'm receiving those server sent events over HTTP. Okay, so that we've covered how to access these models most of the time, all the time, pretty much over API. And we've covered both kind of raw prompt access to these models, which is what you would get if you were just getting raw access to an open large language model, And we've looked at this sort of convenience around chat completions and applying those um, prompt templates as just on the fly. So not putting that on the user. Okay, let me pause for a second. I'm going to just check real quick for questions. So say you had something like the color of the White House is that has an exact answer. Will it still generate random answers? So great question, Zach. And his question is, would you use a different model for that? So this is an autocomplete model, which means that the thing that it is good at is producing coherent text. There's no reason why we should think that a model like this produces accurate text necessarily, other than the fact that it's been trained on a whole internet's worth of data. And there's a lot of places on the internet that talk about the colors of things or general information or the Go programming language or whatever it is. So you shouldn't assume that the output of these models is accurate. What you should assume is that you have to somehow check or validate the output. At Prediction Guard, we use factual consistency checking models, which I'll show in a bit, to confirm that and validate that output. But there's really no other way to do that other than if you put a safeguard in place, like a factuality check or some other way to verify the output. Otherwise, it's sort of free game. Although it might work in many cases, it might also fail spectacularly. Cool. Yeah. Yeah. If you're trying to use Llama, I see a couple of you trying to use Llama. So our API client is it should. It hasn't been fully validated across all large language model providers. Llama has its own API, so that's likely why it's not working in that case. Unfortunately, the state of large language models is that the different systems that you use don't necessarily all have the same API. Cohere's API is different than OpenAI's, is different than whatever. We've standardized ours to be basically OpenAI compatible, although we provide extra functionality on top of that. So cool. Another question, does building a customer support bot require training a model from scratch? Definitely not. You should never, ever, 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 ever train a model from scratch ever in your life into the future. What you need to do is grab an open model or a system like ours that allows you to access an open model. And we're going to talk about introducing your private data, your company's data into that here in a second. But you'd want to inject your data into the prompts to the model, most often via Retrieval, which we'll talk about here in a second. But eventually, if you needed to, you could fine tune a model, which doesn't require you to train it from scratch. How do you fine tune an existing open model? I'll get to that at the end if I can, Timu. What I'll say is, again, 95% of the use cases that you're going to encounter do not need you to fine tune a model. So people often jump to fine tuning. It's my very, very, very strong recommendation that you think about this. So this hierarchy, if you have not tried all of these things to solve your problem and you're thinking about fine tuning, you've thought about fine tuning way too fast. Most all of your problems can be solved using these techniques, which don't require fine tuning. Good question. All right, let's hop back into the examples to get a little bit further on past general calling of LLMs. So we're going to go on to this prompt engineering, and here. There's a couple things that you'll notice. One is I just hard coded a bunch of prompts. That's not how a real system would work. Somehow I need to make that dynamic. Also, there's sort of, this is a one shot thing and nothing is interactive or happening on the fly. So here we're going to deal with a couple of those issues. The first one of those is what is generally referred to as prompt templating. So uh, there's a variety of inputs that you might get from a user. Like, let's say that you are creating a customer support bot, right? And the user asks some questions. Well, you want to answer those questions maybe based on the policies of your company or based on the previous previous responses that were good or something like that. So likely what you want to have is some sort of template under the hood that's like this. So let me just word wrap here. So you want to have probably something like, hey, read the context below and answer the question. If the question can't be answered based on the context, then explicitly say, sorry, I can't answer this question. So then you have a template like this that allows you to inject a certain context on the fly and a certain user question. And this then gives you a scaffolding for responding, which kind of reins in how the model is going to respond. It gives you a chance to inject your own data to ground the response, but you still have but you can still insert the user question. So again, this most of the time happens behind the scenes of AI systems, where you have some templates or a set of templates like this for different purposes, for summary or for certain types of data or for certain operations, and you're managing a set of prompt templates that you update on the fly. So here I've got that prompt template, and now I'm going to, instead of providing just a query, I'm going to provide, or just a prompt, I'm going to prompt template that with a certain context. And the context I'm going to use is this one. This is just a case study that I pulled from golang.org, from Capital One. Do we have any people from Capital One on? I stole your case story from golang.org. It's public. Hopefully that's fair use. So I have this context in this text file. And then I'm going to, oops, that's the wrong one. Let me just go back here. There we go. I'm going to read in that text file. I'm going to provide that as the context for the question answering, and then give it the query. And so when I run this now, I can say, when did we add an additional endpoint to the API? And in fact, this talks about adding an additional endpoint to the API in mid 2016. So let's see if now this is able to answer given the prompt template. All right, cool. We added an additional endpoint to the API in mid 2016. So let's just modify this and see. Let's say, how did Go help us? All right. Oops. Go help the Capital team at Capital One in several ways, in fact, and very very great ways, I'm sure. So this is prompt templating. That's a great tool that you should use. Most of the time, you're going to have many of these prompt templates that you can pull on for various scenarios. But also, you might want to have different sets of context that you ask questions over. So here I've got the same case study, and then I've got something from the Arden Labs blog about getting friendly with CPU caches, which sounds like fun. So again, similar type input, except this time I'm just providing the file that I want to ask questions over as a command line argument, and then I'm setting up a loop to get input from the terminal. So yeah. So let's try context one, which I think is still the Capital One blog. So I'd say, when did we release our new API endpoint? Okay. Apparently it didn't find it that time. Let me just, I think it talks about what did the thing talk about? Oh yeah, it talked about uh, didn't talk about release actually, so that's probably good. When did we add our new API endpoint? So there, and then like, how did Go help us? Cool. So there you go. And that provides over that context. And then we can go switch context now and say, what is L1 cache? And so here it talks about the L1 cache. Okay, so that gives us, so up to this point now we've done a small bit of prompt engineering to get a proper question answering template in place here, and we've at least templated out that we can use different contexts to answer questions on the fly. Next, we're going to add in some additional things to make this all work a bit better. I'm going to go ahead and go on to that because I want to make sure we get through it by the end of the webinar. But I promise I'll circle back with questions. So let's go ahead and go to this. So let's say that we don't want to. I mean, most of the time, you're not going to be providing context to these models via text files. That seems rather silly. You might be getting that context, let's say, from websites or maybe internal documentation or something like that. Here, I'm subbing in kind of websites generally for that. So let's say that we want to pull a website and then answer questions from that website. Well, I'm going to use this HTML to Markdown package. Thanks, Johannes, if you ever hear this. And what I'm going to do is pull the contribute field from the Go website. So if you look at this page, if you look at this page, then it has a bunch of info on it, right? Blah, 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 big page. So we're going to pull that. We're going to convert it to Markdown. So I have that Markdown string. I'm going to do a little bit of cleanup on this. And then I'm going to do an interesting thing that will allow us to better use this functionality. So in the previous example, I had a small amount of context. This isn't that much text, right? But if I have a full page of information like this, most of these models, including the sort of closed ones, the GPTs or whatever like that, are not going to do that well over large contexts of information. So they just simply don't work very well because they forget a bunch of stuff in the middle. So what we're going to do is we're actually going to take that larger context and we're going to split it out. And the way that I like to split it out is in a split size with an overlap. So basically rolling windows of this text that overlap by some degree. That way you're not arbitrarily cutting off some sentence and losing context. Just to give you a sense of what this will look like, I'm going to print one chunk out of here and then the number of chunks that I'm splitting this into. So here. Remember where I'm at. There we go. Cool. And so this pulls that, and then you can see I get 59 chunks. This is kind of about the size of one of those chunks, and then they're overlapping. So that's thing one we want to do is split out our text into chunks. Next, what we're going to do is we're going to vectorize those chunks. What this means, I have a picture here that might aid this, is the following. We're going to take whatever documents that we want to operate on, split them into chunks, which is what we already did, and we're going to convert each of those chunks into what's called a vector representation or embedding. And this vector representation or embedding is going to allow us to do semantic search over these chunks. All those fancy words mean is that if I have a user query input and I convert that to this set of vectors, and then I have chunks in the same space, in the same vector space, I can just do a straight up comparison between this numerical representation of my user query and this numerical representation of my chunks to get the closest matching chunks. So it's a search problem, it's a retrieval problem. I then get the relevant chunks, I plug them into my prompt template and answer my question. And then hopefully I have success, right? So here, what I'm going to do is I'm going to do the same thing that I did before, which is grab the website, except this time I'm going to use a slightly different API, the one from Cohere. I like their embeddings quite a bit. They also have an open source version of these embeddings. And I'm going to, for every one of these chunks, I'm going to send batches of them to this embedding endpoint, get them embedded, and then I'm going to save that out to an output JSON. So basically, I'm just going to pre-compute all of these embeddings. So here, and this will take not that long. And if I look at that chunks, so now I have a chunk, right, of text, and I have the corresponding vector representation. Now, most of the time, this was already mentioned in the chat, most of the time what you're going to do is you're going to store these not in a local JSON file, you're going to store them in a vector database, which I've referenced here. And the one that I like to use is LanceDB. It's a really great vector database for this and easy to use. But there's any number of them. There's Weaviate and Pinecone, and there's open source ones and there's not open source ones. The same thing with any database. You know, pick your poison. Do you want open source? Do you not? Do you want managed? Do you not? Do you want client server? Do you want embedded? There's all of those flavors of vector databases. This webinar is not about that, but suffice it to say, you would normally store these in that sort of vector database. So now we have our chunks, we have them vectorized. So what we can do now is go back to our next example, where we will do an example search of these. So what I'm going to do here is use this cosine similarity function, which just implements cosine similarity, which is a metric between two vectors, to compare the vector distances between these vectors. So when I have an input, I'm going to load my chunks into memory, and then when I have an input like what is the review process, and I have that input, then I can embed this message and then perform my search over those chunks to get a first most relevant chunk from the data, and then we're just going to print that. Okay. Okay, and here you can see we match to a chunk talking about the review process. And you can see this is very, very quick. Most vector comparisons like this are very quick. So all of that wasn't really AI in the sense that we just solved a search problem, basically. So the first examples, we split the input up, we vectorized it, we did an example search. Now let's actually use this. So again, I'm going to have my question answer template. I'm going to have my cosine similarity to do those comparisons. I have my search functionality, except now I'm going to pull in this chat message to respond to a chat. But in order to know what to respond to in my loop where I have the chat going on, I'm going to search, get that chunk, and then I'm going to provide that chunk to the question answer template on the fly to get the correct answer. So now every time I'm not answering over the whole document, I'm just answering over the given chunk. Okay. So what is the review process like? Okay, blah, blah. And there you can see it matched to something. Looks like it matched to something in the document because it's talking about things that were in there. So that's an example of doing that search on the fly. Again, it can be very, very quick. However, there's a couple of downsides here that we want to take care of. One is our data is basically static in this case. And two, there's no sort of like everything's a one turn thing. So I can't I'm not actually saving any message history to give additional context. I'm not actually chaining anything together to provide extra functionality. So let's do a couple of those things now. Example 5 is just a slight modification on the previous example, where here we're doing the same thing, except here what we're going to do is we're actually going to input a website. We're going to parse that website on the fly, and then answer questions about that website. So instead of having our data pre-computed, this would be like an on-the-fly AI search of a website to answer a question. So here, back to example 5. And you know what? Let's find a cool website like the Linux contribution guide instead of the Go contribution guide. So here's everybody's on the edge of their seat to learn how to contribute to Linux, right? So let's just go ahead and paste that in as our website. So now that website's going to get parsed. It's going to get split up into chunks. And now I can ask, how should patches be separated? Okay, cool. They should be separated into logical changes. How should I summarize my contribution? Okay, to summarize your contribution, blah, 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 blah. Okay, cool. So now I have this chatbot that can answer questions generally from a general website. The last thing that I'm going to do, and this will be my last example here, is just upgrade a couple things about this. This is still, so I've now made the data somewhat more flexible. But now what I want to do is I actually want to make this chained. So I'm going to add something down here at the bottom, which is going to append the user and assistant messages into my message thread to give further context to the question sort of stream in the answering. The other thing I'm going to do is I'm going to chain together something that I believe it was Zach in the comments mentioned before, which is, hey, I don't actually know if any of this stuff is actually useful in the output, right? Like this could totally be making up stuff and I would have no idea, even though I'm grounding it to some external data. And so I'm going to add in a factuality score. This is another call to a model, except in our prediction guard client, we have this factuality piece built in, which is a fine-tuned model for factual consistency checking. We've already done all the prompt engineering and all that. So this is a model checking a model. This is usually called kind of LLM as judge or LLM critic, but we've introduced a good amount of convenience around that, where you can just call factuality and get a score. And it's going to look at the context that it matches to, or the chunk from the website, along with the full message that's generated to actually calculate a kind of probability of there being factual consistency between the output of the LLM and the external data that you consider ground truth. Okay, all of that put together looks something like the following. Okay. And let's grab that website again. Cool. That's loaded in. And I can ask, how should I summarize my contributions? Okay. Again, I get the answer, but notice that the bot is thinking a little bit harder at the end there. So after I get my answer, it's actually comparing this answer with the ground truth data to get a score between 0 and 1 of the factuality. And this is what I would generally refer to as chaining. You can chain all sorts of things together to do amazing things. You can chain together, like if you're solving the problem, like if you want to take in a user email, summarize that email, translate that summary to Spanish, and then send it in a report to someone else. You want to separate out those actions in your LLM reasoning to various chained actions of models, and that's kind of what we're demonstrating here with this factuality score. So, say how should my patches be separated? Cool. It's going to calculate the score again. In this case, pretty good. How should um, I don't know what else is in there, but you guys get the idea. This one's less probable, but still quite probable that it's factual. So let me go back and just summarize here. Some main points, if I could give you some points as takeaways, is if you take away nothing else from this webinar, remember this hierarchy. So solve your problems from simple to complex and use these initial prompting, augmentation, retrieval strategies before you go to fine tuning. And basically, you're never going to have to train a model from scratch. But 95% of your use cases should be solved by these things at the top, which are hopefully simpler and easier. In these slides, here's a link to Prediction Guard, which I mentioned. If you want to try out some of these things, or if you have further questions, you can go to, like I say, this Discord channel. Just join up, and happy to chat about anything and make sure that we can get you experimenting with some LLM models. Here's also a link to my podcast, and then a few other resources that are really good. With that, I can go ahead and stop sharing my screen. And I would like to sort of definitely thank Arden Labs again for their time and doing this, and also thank them. We've been fortunate enough to spin up a new key partnership with Arden Labs. They have very quickly leveled up a lot of our infrastructure and our client-facing, our developer-facing things. And there's a lot more good things to come from this sort of Arden Labs and Prediction Guard partnership. So look for that in the future. And if you're developing out AI systems, or maybe you're looking at how to adopt AI in your organization, and Arden Labs is either already a trusted partner or they should be a trusted partner because they're great, reach out to them, because we've been working with them to make sure that that companies can deploy safeguarded private AI in their context. So really excited about that. I know it's the end of the hour, but I'm going to stick on and answer a few questions that have come through. So yeah, thank you all. If you have to leave, that's fine, but I'm going to go back through and answer a few questions now. So let's see. So the question, I always thought you had to do some fine tuning to get chatbots to know about specific info. If that can be avoided, that's really cool. Yes. So there's a general misconception that these chatbots that know about certain info, like especially your private company info, require fine tuning. There's certainly people that have done that out there, but like 99% of the cases where a company is creating a chatbot and integrating their own private data or knowledge, that doesn't happen with fine tuning. That happens with this retrieval augmented generation, which I showed here. Question about the rolling window when we created the chunks for the retrieval augmented generation, asking if this is similar to what the old code interpreter in ChatGPT used to do. It's different than that. So what we're doing here is we're creating a sort of set of contexts. We're pre-computing a set of contexts that can be injected into the model prompt to answer questions or to give context to the output. What Code Interpreter does or did, and what code assistants, some code assistants do, and we actually do this with SQL generation, is the following. So generally, large language models are good at autocomplete, but they're not necessarily good at data analysis. They're not necessarily good at analytics. And so one way around that is to use a language model to generate, let's say, the Python or Go code to do something. And then you execute that just with normal Go or Python, and then return the results to the screen or return the results to the model for output to the user. So the way that we do this very often is with SQL rather than Python or Go. So if you have a database, right, and you want your user to ask a question like, how many more accounts do we have this month than last month? That's an analytics query. So you can use a model to generate the SQL to execute against your database, execute that, and then return the result to your user. And that's kind of a nifty way of doing that. Adam asks, how important is the context window of a model? I know Gemini announced 2 million token window, but I don't understand what that means. Yeah, so context window means how much or how big your prompt can be that you input to the model. So most models will have a sort of context window of around a few thousand tokens, which is normally like, a couple thousand words, let's say. So these models that are talking about, 2 million tokens or however many million tokens, they allow you to input a lot of text. Sometimes that can be good, but I think in general, I'm quite skeptical about the usage of these large context models. I see much more enterprise usage out of smaller context windows. And the reason for that is like, it's almost the same as like, imagine these models are a college level intern that you hired. It's much easier for you if you can to tell that college intern, hey, here's a piece of text. Could you answer a question out of this for me? If that piece of text is a paragraph long, that college intern is going to do much better at answering the question than if you put in a whole book. So I think right now, the reality is that I don't know, my own experience is I haven't been super impressed with that capability, but maybe it'll advance in the future. It feels like there are many areas that feel inefficient. Chunking with overlap could be better to chunk on context. Yeah, logical areas. Yeah, so if you know about like in the case that I did, I don't write the websites that I was scraping, right? So I have no context into those websites. And I just did it the sort of naive way of chunking and overlap. If you know something about the structure of your data, you can totally be a ton more efficient in how you do those chunks. In Python, LangChain provides a chunker for something like Markdown. So LangChain, for those that don't know it, is a convenience library in Python that allows you to do various things related to vector databases, chaining, agents, a bunch of things. So there's definitely convenience functions out there. The one thing that I would kind of, just from my own experience working with customers is, as Go engineers, you're used to handling errors and being good about your debugging. Just embrace that as you build these systems, because if you hide a lot of things around convenience functions that set up agents and do chaining with a lot of things happening under the hood, most of the time you have resiliency issues with those agents. And so most of the systems that we are building for people or working with people on are, yes, they are chains, yes, they are agents, but we have very specific knowledge of how the chain operates, and we're controlling the templates and all of that stuff. So just an FYI. Yeah, question would be interesting to see it translate from English to Spanish and then back to see if it's different words. Yeah, I worked in the translation industry for a while. That's called back translation. It's actually a very common technique that's used, especially if you don't know the target language, to see if a translation is maybe of good quality. Would there be a way for a user to expose sensitive data in a response, either intentionally or unintentionally? Yeah, so this gets to kind of the core problem that we're solving at Prediction Guard, which is safeguarding these models with things like the factuality check, but also deploying these models in a scalable way in private, secure environments. Sometimes you may that like if you can deploy a model and you're sure that you're not sending all of your data over to OpenAI and they're going to train a model on it, then your data is not going to be exposed in a future version of GPT, right? That's a lot of people's concern. So hosting these models in a resilient and scalable way in private infrastructure, that's one of the things that we specialize in. Also, what people are doing is we have some of this built into our system, but people are kind of putting privacy filters like for PII and other things in front of their models to make sure some of that's not leaked. What's a good prompt template guideline to include to avoid the response making a direct reference to the fact context was provided? This is just a matter of playing. So, uh, welcome to the world of prompt engineering, which is much more like psychology than it is programming in some respects. So basically, what you want to do is iteratively change that prompt and that system prompt that you have, the wording of that. Think about how you would explain this to a college level intern and then test the output. You want to have a test set of outputs that you can validate and try to work towards the behavior that you're after. Cool. Uh, so, question about Prediction Guard's model, free to use. For this amazing audience, if you join our Discord channel, we'll definitely figure out a way for you to use the models in an evaluation way. Obviously, it costs money to use these models, and our system is really an enterprise system for those of you that are trying to scale enterprise use cases of AI. If you're just wanting to hit a few models, there's definitely a lot of ways to do that. Llama was already mentioned. That's fine to run at a small scale. But yeah, join us in Discord. We'll make sure that you can get experimenting and explore your use case. Would you need to fine tune if the company wanted the chatbot to know about its 500K byte sized code base? So it depends. So if you're talking about like a code base, most of these models do understand code quite well, and I would think that like a deepseek model, for example, those are trained as general code assistants. If you're able to do a semantic search over your code base and do it in the same sort of retrieval way, that's certainly what I would start with. So I would not start with fine tuning, but I would convince yourself that that sort of retrieval using an open model like DeepSeek didn't work, because fine tuning is just you might fine tune and it might work worse than the original model, which happens to a lot of people, which is sad. Would fine tuning the embedding models be appropriate? I found that sometimes when you prompt and documents are asymmetric in length, more irrelevant documents are retrieved. Good question. I wouldn't say that would require fine tuning of the embedding model. I would say that would require advanced RAG techniques. So if you just search for advanced RAG, there's like naive RAG, which we did, which is do a semantic vector search and pull a document out and answer based on that. There's also many advanced RAG techniques. These include doing a hierarchical search over summaries and then individual chunks. It includes methods to have an LLM reframe your query to make it better suited for retrieval. It includes doing hybrid search with full text search plus vector search. There's like an increasing number of strategies to use. But if you just search for advanced RAG, you'll see some of those things come up. And then a question, why AI applications have to be developed in Go? What benefits does it provide over Python? Well, Go offers its sort of standard sets of benefits over Python in terms of readability, speed, concurrency, all of those things. Many places, basically, AI is going to benefit every business operation and software system that's being developed. And because many of those at the systems level, the backend API level are written in Go, it makes sense to do AI in Go because uh, those will be influenced. So I'm not so much saying that people should never write AI applications in Python. If that works in your infrastructure and that's how your infrastructure is set up, then great. But a lot of companies have a big team working on Go applications, and they don't have to rewrite everything in Python or integrate Python services or hire a bunch of Python people to do that. They can do generative AI in Go because most of these systems work over API. Cool. Thanks for answering my question. What would be the de facto framework in Go for building Gen AI apps? Well, in a very biased way, I would say Prediction Guard. We've got increasingly and better support for Go. There, you could do text completions, chat completions, factuality checks, toxicity filtering, PII filtering, prompt injection filtering, language translation. We're compatible with vector databases and all that stuff. So, I mean, that's my very biased opinion that it should be done with Prediction Guard. But there are community projects as well. I know there's some effort to port some of the convenience functionality of LangChain over into a Go LangChain project. But most of the time, like I mentioned, a lot of these things, it's still software engineering. People think that developing generative AI is sort of different than software engineering, that you still have to write tests and think about the architecture of your project and all of that. But all of those things still apply. It's a question of how much convenience you want and how much sort of pre-built systems around the vector databases and other things you want. So, all right. Well, let's see. As a junior engineer, I'd love to make some chatbots, but the cost of hosting has me intimidated for projects with probably no users. Can this be done relatively cheaply? Yeah, if you're just looking to do a cheap project, Jeffrey, then what I would recommend that you look at is something like you can sign up for a trial key on a bunch of the different LLM providers, but also I would highly recommend that you look at Hugging Face. Hugging Face is a community for AI models, data sets, and development. They just announced $10 million that they're giving away in GPU compute for those experimenting with this technology. And you can do that through their Hugging Face spaces. There's there's limitations on how much you can do there and what you can do in that spaces place, but it may be a way for you to get hands-on and get going. So yeah, that's one recommendation, is to check out that. I think that's called Zero GPU. Yeah. All right. Well, that wraps it up for us. Thank you so much for attending. Thanks to all who stayed up late to see this webinar. It was really great. Thank you for your questions. Please reach out, and we'll see you in Discord or elsewhere. Thank you all.